This question, we are given that there is a cart of mass m with negligible friction along a track v1 to the right. So we've got a positive direction like this, and we have a cart with a mass m moving with a velocity v1 to the right. It's frictionless. It collides with a cart of mass 4m also moving to the right. So now there's a big cart, 4m, speed v2 to the right. So the two come together, and afterward they are stuck together. And move off like so. Now, first thing we notice is that this, when we look at our things, this is not an explosion. It's not a bouncy collision. It is a sticky collision, and sticky means it's inelastic, which means the kinetic energy is not conserved. So this is just from the situation. And since m, the first m, is overtaking the second m, v1 must be greater than v2. So what we expect then is afterward, the velocity that they will have together will be intermediate between v1 and v2. Can't be more than v1, can't be as much as v1, and it's not going to be as little as v2. So our choices now, which two principles, conservation of momentum or mechanical energy, must be applied to determine the final speed of the carts? And so first choice, only conservation of momentum, because it's lost by one cart, it's gained by the other, and there is only one unknown quantity. So let's identify the different clauses here. Only conservation of momentum. That is true. We must be applied to determine both conservation of mechanical energy and conservation. And it turns out conservation of mechanical energy does not apply in any collision because we have inelastic collisions when it's sticky. So this one's out. Both mechanical and momentum, we think not, because neither cart changes direction. That's irrelevant. The directionality doesn't matter. Either conservation or conservation, no, we definitely, this is a momentum situation, so it's choice A. Now, why isn't it conservation of energy? Well, conservation of energy, remember, the total energy of the system is conserved. So we have total mechanical energy and Q, that's what we care about in physics, and then we've got a bunch of other types. So if we're talking about conservation of total mechanical energy, we're dealing with kinetic energy, gravitational potential energy, elastic potential energy, and even rotational kinetic energy. But that's not a part of this. So there's no change in height, so there's no change in potential energy. There's no elastic potential energy involved here. So we're dealing then plus others. For energy to be conserved, it must be kinetic and others, but the kinetic energy is not conserved. We know that. So there's no way to use conservation of energy from this because these other types of energy are degraded forms of energy. They are thermal and vibrational and sound and so forth, and they are lost to the mechanical energy system.